Let's have a look at this interesting problem. 18 employees were shortlisted for a post in a company. Out of the shortlisted employees, 11 were men, 6 of whom live in Sunyani. 12 were married people, 8 of whom live in Sunyani. 12 residents of Sunyani and 9 married men. There was only one single woman who lived outside Sunyani. How many of the shortlisted employees were A. Married men from Sunyani and B. Single women? This is a very interesting problem. It is a 3-set problem. Let's try and identify the sets here. The question says that 18 employees were shortlisted for a post in a company. So the total number of employees shortlisted is 18. That will be our universal set. Let U be the universal set. So U is equal to the employees. Out of these 18 shortlisted employees, 11 were men, 6 of whom live in Sunyani. 12 were married people, 8 of whom live in Sunyani. 12 residents of Sunyani and 9 married men. There was only one single woman who lived outside Sunyani. If you consider the question carefully, you can see that the 3 main sets are men, married people, and residents of Sunyani. Let M represent the sets for men, S represent the sets for residents of Sunyani, and P represent the set for married people. Now let's find the members that belong to each set. The question says that the total number of employees shortlisted was 18, so the number of U is equal to 18. Out of these 18 shortlisted employees, 11 were men, so the number of M is 11. 12 were married people, so the number of P is 12. And we had 12 residents of Sunyani, so the number of S is 12. Out of the 11 men, 6 live in Sunyani. So these 6 people are men who live in Sunyani. They are men and they are residents of Sunyani. So they belong to set M and set S, which means that M intersection S is 6. Out of the 12 married people, 8 of them live in Sunyani. So these 8 people are married people who live in Sunyani. They are married people and they are residents of Sunyani. So they belong to set P and set S. So P intersection S is 8. Then we had 9 married men. 9 married men. So these 9 people are men who are married. They are men and they are married, which means that they belong to set M and set P because they are men and they are married. So M intersection P is 9. Now let's look at the last statement. There was only one single woman who lived outside Sunyani. This person is a woman, she is single, and she lives outside Sunyani. She is a woman, which means that she does not belong to the set for men. She is single, so she does not belong to the set for married people. And she lives outside Sunyani, so she does not belong to the set for residents of Sunyani. So she does not belong to any of these 3 sets. So that will be M union S union P complement, and that is 1. Let's represent this information on the Venn diagram. We have the data here, and this is our Venn diagram. The number of U is 18, number of M is 11, number of P is 12, and number of S is also 12. Let's assume that the members that belong to all three sets is S. So M intersection P intersection S, let's assume that is X. From the data we have here, we have M intersection S to be 6. We know that on our Venn diagram, M intersection S is this region here. But we have already allocated this region, that is the region where all the three circles intersect, to be X. So if the total thing is 6 and this part is X, then it means that the remaining part, that's the part shaded yellow, is 6 minus X. We have P intersection X to be 8. On our Venn diagram, P intersection X is the region between P and S. That is the region shaded yellow here. But we already know that this region, the region where all the three sets intersect, is X. So if the total thing is 8 and this part is X, then it means that the remaining part will be 8 minus X. The next one, we have M intersection P. On our Venn diagram, M intersection P will be the region between M and P. We already know that this part is S. So if the total thing is 9 and this part is S, then it means that the remaining part will be 9 minus S. We have M union S union P complement to be 1. This will be the members that do not belong to any of the three sets. So they will be outside the three circles. We have that here. We still have some empty regions. This side, that is the region for M only. Let's represent that with a variable A. So M intersection P complement intersection S complement is A. This region, that's the region for P only. Let's represent that with B. So M complement intersection P intersection S complement is B. And this region, that's the region for S only. Let's represent that with C. So M complement intersection P complement intersection S is C. Now that we have all the regions filled up, let's solve for each set. We are going to begin with set M. The total members in set M is 11, which means that if we add everything in set M together, we should get 11. So A plus 9 minus X plus 6 minus X will give us 11. This gives us A minus X plus 15 is equal to 11. A will be equal to X plus 11 minus 15. 11 minus 15 gives us negative 4. So A will be equal to X minus 4. Let's solve for set P. The total members in set P is 12. So if we add everything in set P, we should get 12. B plus 9 minus X plus 8 minus X is equal to 12. This gives us B minus X plus 17 is equal to 12. B will be equal to X plus 12 minus 17. 12 minus 17 gives us negative 5. So B will be equal to X minus 5. Let's solve for set S. The total members in set S is 12. So when we add everything in set S together, we should get 12. So we have C plus 6 minus X plus 8 minus X is equal to 12. This gives us C minus X plus 14 is equal to 12. And so C will be equal to X plus 12 minus 14. And this will give us C is equal to X minus 2. So we have A to be X minus 4. We have B to be X minus 5, and we have C to be X minus 2. We know that when we add everything in the Venn diagram together, we should get the universal set, which is 18. So let's do that. We will have X minus 4 plus 9 minus X plus X minus 5 plus 6 minus X plus 8 minus X plus X minus 2 plus 1 is equal to 18. This gives us x plus 13 is equal to 18. And so x will be equal to 18 minus 13. And 18 minus 13 gives us 5. So x is equal to 5. When we substitute this in the Venn diagram, we are going to have 5 minus 4, which is 1. 9 minus 5, which is 4. 5 minus 5, which is 0. 6 minus 5, which is 1. 5. 8 minus 5, which is 3. And 5 minus 2, which is 3. So we now have all the members that belong to each region in the Venn diagram. Let's go ahead and answer our questions. The question says that we should find the number of employees who were A, married men from Sunyani, and B, single women. Let's take the first one, married men from Sunyani. So the people that belong to this set are men, they are married, and they are from Sunyani. They are men, they are married, and they are from Sunyani. Which means that they are the members that belong to all three sets, because M is the set for men, P is the set for married people, and S is the set for residents of Sunyani. So if we are looking for men who are married and live in Sunyani, then we are looking for members that belong to all three sets. And on our Venn diagram, the members that belong to all three sets will be 5. So it means that 5 of the shortlisted employees were married men from Sunyani. Let's look at the second part. It says that how many of the shortlisted employees were single women. We are looking for the number of single women. Because they are women, they don't belong to the set M, because the set M is for men. And they also don't belong to the set P because they are single. So the single women will not belong to set M, and at the same time, they won't belong to set P. After taking out set M and set P, the remaining regions are this, which is 3, and this, which is 1. So it means that the people that belong to these two regions are single women. 3 plus 1 gives us 4. So it means that out of the shortlisted employees, 4 were single women.